How's it going? Today's aim is going to be, let's find possible inputs and outputs for a function. Okay, I apologize for the shadow. Try and find a better spot for the next video, but you can still read everything, I believe. All right, so this lesson 10 is going to be domain and range, first part of it, a two-part lesson, which you'll do the second part tomorrow on Tuesday. All right, so 10.1, number of barks. Earlier, you saw a situation where the total number of times a dog has barked was a function of the time in seconds after its owner tied its leash to a post and left. Less than 3 minutes after he left, the owner returned, untied the leash, and walked away with the dog. All right, so I actually don't remember doing this graph, and I don't think it was on any of the homeworks. I think it was from very, very early in this unit before we started covering the material. So, but that's okay. We don't really need to see the graph to answer these questions. What we do need to understand is what the input and output of this function are. So if we see a situation and we've got to identify our two variables, right? So I see one variable is the total number of times a dog has barked. All right, and that is a function of time in seconds after its owner tied a leash to a post and left. So if I see time, I immediately know that's going to be my x. All right, total number of times the dog barked, that's going to be my y. So if I'm looking here, could each value be an input of the function? Be prepared to explain your reasoning. Well, if I'm talking about an input, that's referring to x values, right? X is input, y is output. So could any of these values be time in seconds after its owner tied its leash to a post and left? So could a dog be barking 15 seconds after its owner tied it to a post and left? Yeah, definitely 15 seconds could work. 84.5 seconds. Sure. We see that it's going to be less than 3 minutes after he left. So 84.5, if we're talking about how many minutes that is, that's a little bit less than a minute and a half, because a minute and a half is 90 seconds. So that also works, right? We can have half a second. We can have a quarter of a second. That's totally valid. 300 seconds. Well, theoretically, the dog could be waiting for 300 seconds. If we divide 300 seconds, if we divide that by 60 seconds, right? Because there are 60 seconds in a minute, that's going to equal 5 minutes. They say that the owner is coming back 3 minutes after. So I would find it hard to believe that the dog would still be barking 5 minutes after when it's just walking with the owner, but who knows? I mean, dogs bark for whoever knows what reason. So I would argue that 300 is probably not on the graph because they say it's 3 minutes after he left, but I mean, theoretically the dog could be barking. It wouldn't be unrealistic. But I'm going to say probably not. All right, 2. Could each value be an output of the function? Be prepared to explain your reasoning. Well, the output is y, and that's the total number of times a dog barked. 15 times, sure, I can see a dog barking 15 times. Dogs love to bark. 84.5 times, well, you either bark or you don't bark. There's no in between. So having a fraction as a number of times a dog barked doesn't make any sense. So I'm going to say no. And 300 times. I think someone would probably do something to that dog if it was barking 300 times in 3 minutes, right? That's like 100 times a minute. So every second, for 3 minutes straight. I know some dogs that bark a lot, but that just seems totally unrealistic. So I'm going to say probably not for that either. So that is all for 10.1.